And I always forget until I start asking them, like, I can't change now. If I remember to do that next term, I will.
But carrot's just the vegetable that everyone thinks of, and 6 has nothing to do with it.
Damn good question. Do me a favor. The question was, what if 6 has nothing to do with carrot? Do me a favor. Next time you guys walk into one of your classes, go up to your classmate and go, dude, give me a vegetable. And write down what they say. Can everybody do this for the next week, until we have class again? Just walk up to people, vegetable, give me a vegetable, give me a vegetable. And just write down what they say and bring it back on Tuesday.
Okay.
Is that cool? And we'll see if we get anything close to that graph. That would be freaking awesome. I don't know the answer. Statistics. Yeah, good. Good. Let's readdress that, shall we? Yeah, that's good. Thank you, sister. All right. Anyway, back into this. Here's some words. Finger, refused, dedicated. What is the average length of letters per word of those 3 words? Please give me 1 decimal place of accuracy.
7.
1 decimal place of accuracy. I think it's not exact. 7.5. 7.5? Well, let's figure it out. 6.
3.
7 is 13. Yeah? 14, 15, 16, 17, 18, 19, 20, 21, 22. Divided by 3 is 7.3. Right? 7.3 repeating. So 7.3 as an average to 1 decimal place. Okay. I'm going to ask you to do a similar calculation in a second. You won't have enough time to actually do what we just did, which is count all the letters up and divide by how many there are. But I want you to give me your best guess estimate as to what the average length of the words is in the next block of text. Okay, you ready? You'll have 10 seconds. Best guess estimate to 1 decimal place, please. Here we go. You're wasting time laughing.
If we put them all together?
You're wasting time asking this question. Estimate. Estimate. Oh, it's too late.
7.
4. Good. Now, we're going to collect this organized. I want to 1 decimal place of accuracy. Anybody recognize it? Anybody recognize the soliloquy?
Princess Bride.
Inigo Montoya from The Princess Bride, greatest movie ever made. Okay, so what we're going to do now is we're going to collect that data. Oh, you had a question, my friend. Go ahead.
Oh, no, I was gonna...
Oh, give me your guesses. I want to collect them orderly. I want to collect them orderly now. I want to turn this off for a second. We'll come back to it. So the reason I picked this one is because of the results I get are usually they behave pretty consistently. This is called a stem and leaf plot, or sometimes it's just called a stem plot. Stem and leaf plot, or just a stem plot. What these are useful for, this is numerical. I asked you guys to give me an average length of word, right? So you're going to give me a number. So we're back to quantitative data. But a lot of times when you're collecting data in the field, like for you natural resource majors that are out there, a lot of you guys are going to have to go out in the field with like a pencil or maybe an iPad or something like that, but generally a pencil and a piece of paper because you don't want you getting iPads wet in the forests in the Pacific Northwest. And you have to count things like forbs or the size of grasses or the number of bushes and things like that. And very often, there's not a whole lot of difference in the certain parameter you're measuring, but there's a lot of precision difference within that. So let me ask some questions. Give me some numbers just so I can get a ballpark of how big. Did somebody say 4? Do we vote for 4? Anybody go below 4? Like 3 point something? Kelly, what'd you say?
3.
3. Anybody go below 3 point something? Okay, so 3 is the low end. Let's go on the high end. Do we have any 8s? Not anybody above 8? 7s? We have some 7s. See, case in point. 3, 4, 5, 6, 7. There's not much variation. There's not much variation between 3 and 7. So that is a perfect setup for a stem and leaf plot. Here is what these are what are called the stems. When you don't have a whole lot of stems, now we're going to have a whole buttload of leaves. 3 point what? Shout out to me what your points were. So Kelly, you were 3 point what?
0.
3.0 even. Okay. Any other 3s? How about 4s? Shout them out. 4.1. 1. There are 2 1s over there, I think.
0. 4.0.
Were there 2.1s as well? Did I hear 2 guys say it or just 1? Okay, so 0.0, 0.1.
4.
4, and then an 8 as well. Make sure I hear you guys.
5.
2 5s. Ooh, I better run out of space here. That might be okay. We'll see. Anybody else? 4s?
4.
4. Notice, now some textbooks will gripe and say you have to have these things in numerical order. I don't care about that. I'll explain why momentarily. Okay? Any other 4s? 5s?
3.
3?
3.
3? 3 3s?
2, 3.
2, 3?
0.1.
0.1, I heard another 3. We got a mode. 4, 5, 5. Any more? 6s. 3, 7, 1, 4, 2, 1. Was there one more I didn't get? 8.
I said 0.3 too, but.
This wasn't you up here, Sarah?
No, it wasn't.
Okay. 0.3. What I'm trying to do is I'm trying to make each number take up the same amount of space in the graph, if that makes sense. You'll see why momentarily. Anybody else in the 6s? 7s?
0.3.
0.3?
0.3.
0.3? 0.3.
All right.
I wonder if I loaded that too by doing the average of 7.3 earlier. Curse you, psychology. Anybody besides 0.3? 0.8. What else? That's enough. You get the point. Okay, no pun intended. So, do you see how this is a histogram? If not, turn your head 90 degrees to the right. You see? The numbers themselves stack up to make bars. It's a very specific kind of histogram when you don't have a whole lot of variation this way, but you've got a bunch of potentials within each one of those stems. Stems, leaves. It's very specific. I'm not saying it's used all the time, but they are used in some industries to collect a bunch of data that has these characteristics. Natural resources comes to mind. My brother-in-law Rufus used to work for FIA, constantly using these things when he's out there collecting his little data in the woods, Nova Woods. Cool? Makes sense? That's a stem and leaf plot. Notice it is, again, a histogram type. It's a type of histogram type jargon, if you want to think about it that way. Any questions so far?
What's the answer?
Oh, it's about 4. It's literally, I think it's almost exactly 4 just below, I think 3.99 or something like that. The reason is, you look back at that block of text, and people always miss this.
I just see all the big words.
Yep, that's called bias, Sarah, and that's exactly what the problem is. When you look at this, there are a ton of 1, 2, and 3-letter words in the block, but your eyes aren't drawn to that. Your eyes are drawn to the large ones, like slaughtered, and things like that. So you're not looking at those little tiny words, each of which count as a number of the set. I think there's just about 100 words, I think, in that block of text, maybe 150 or something like that. But on average, it's about 4, almost exactly 4. I used a word to count them up for me. Pretty fun, huh? That's an example of sampling bias, because you guys went too large. Almost every single person in the class went too high on that. And that's because your eyes are drawn to the larger ones. We'll deal with sampling bias in 244. Don't worry about that right now. Cool? One last kind called a dot plot. This is like my favorite because he's so specific and so particular. I'm going to make some Excel videos so you guys know how to make all these things in Excel too, because they're not the easiest things to put into Excel. Okay. I'm going to collect one more series of data from you. One more, and then I'm going to stop asking you